Hello everyone. So in this video, I will present the paper I reviewed titled Tree of Thoughts: Deliberate Problem Solving with Large Language Models. So this paper actually will introduce a new structure, new reasoning structure of the large language model to allow the LLM to solve more complex problems like math problems. Okay. Yeah. So the authors of this paper from Princeton and the Google DeepMind. So they developed this new structure of this, I mean, of the large language model. Yeah. So first I will introduce the background. So, we know recently the large language model has been applied or implemented to solve a series of uh, questions or has lots of like applications like the text to text translation, the speech to text translation, and also we use the large language model to develop the chatbot and also the data cleaning or anomaly detection. Yeah. So using the large language model, so I mean, emphasize the strength of this model in managing the short range and sequential reasoning tasks. Okay, yeah. And these days, I would say a general method for the reasoning structure of large language model is the chain of thoughts. So people use the chain of thoughts framework to improve the reasoning capabilities. Yeah, by generating the step-by-step intermediate outputs. But this the current reasoning structure of the large language model, this like a COT chain of thoughts has some limitations in handle the tasks requiring the long-term planning and multi-step decision-making questions. Yeah, for example, the math question. So I think all of us may hear heard the news. So I mean like the ChatGPT or this large language model cannot solve the math questions properly or efficiently. Yeah. Um, and this reasoning structure, driven by the traditional reasoning structure like the chain of thoughts, yeah, has some limitations. So these limitations will, hinder the applications of the large language model to complex reasoning tasks. Like this paper they mention several applications like the tic-tac-toe, the Sudoku, the game of 24, or any like real world problems requiring the sustained reasoning. Yeah. And I would say in the limitation of this current COT based large language model in handling the long-term planning and the complex problem solving will restrict their applications in some like applications, yeah, like the healthcare, the finance, and the legal analysis, because uh, since this model when solving this long-term decision making or long-term questions, this model cannot provide accurate answers. So they can generate the some answers, but it's not accurate. So we cannot, use this answer to these applications. Yeah. And this slides actually, the following two or three slides summarize the current reasoning structure of the large language model, like the chain of thought and the traditional or the original structure. So this slide shows I would say the traditional or the initial reasoning structure of the large language model. We call it an input output prompting. So here you can see just from the text. So this structure is like you provide the input and then the language model just analyze your input and generate output for you. Yeah, and here the right side of the slide shows the example. For example, when solving the game 24. So this one shows a five shot uh, planning. And so if you see the text within the red block, So this is like a one example, and you only provide the input, whole numbers, and they give you the outputs. Yeah, they give you the outputs, and they give you the correct output. So there is no, I would say, intermediate steps. Yeah, so you just give the answer, then they generate the output. Yeah, and this slide shows the method we just discussed, the chain of thought, the COT prompting. So if you see the structure of this, so we provide an input, and large number will divide it. Will divide your input or will generate several intermediate steps, and each steps actually is a each like a blue block is a step to solve your request, yeah, to solve the input question. And then once we can solve this like a step by step, then we generate output. And again, the right side of the slide shows the like a five shot uh, prompting. And if you see the one example within the right block, so here you can see. So once we input full numbers to solve this, to ask the large language model to solve this game 24. So what they do, they I mean what the large language model does. So large language model, we'll use like a step by step, right? Generates like a, full three steps, and each step we solve like one part of the question, and then at the end we generate the number 24, and we give the answer. So here, compared to the previous slide, but compared to this one, the input output prompting. So the chain of thoughts actually divide the solving process into different steps and solve this. Yeah, and solve this. And so based on the chain of thoughts, they also have the similar structure. Yeah, if you see the right side of the of this slice, yeah, if you see the right side of this slice, they call it a self-consistency uh, chain of thoughts. So they have several chain of thoughts, and each of these generate a answer, and they use the majority vote to select the best answer and generate the output. But all of them, as I mentioned, they use the similar method. Actually, they divide the input. They divide the input into different steps, like step by step, but it's like can only solve the linear reasoning situation. And the main problem of this structure is like once you made a mistake in the first step, then you cannot get the correct answer because it will like generate a totally different answer if the first step is wrong. Yeah, it's the first step is wrong. Okay. So to solve this method, so this paper, they develop a new structure of the reasoning. They call it train of thoughts, the TOT. Yeah, the TOT. So I would say the basic idea or the initial idea of this TOT is based on the research on the human problem solving. Yeah, human problem solving. So if you see the description here, so the research on human problem solving suggests that people search through a combinational problem space. So a tree where the nodes represents the partial solutions and the branches shows the operators that modify them. So this node shows the thought or some like intermediate ideas, and the branch shows the method to combine them. Yeah, to connect the different layers. Yeah, and which branch to take is determined by the heuristics that help to navigate the problem space and guide the problem solver towards solution. So based on this idea, so this idea actually shows the how our brain to solve a long-term or math problem. It's more like a tree, and it's like step by step or layer by layer. Yeah, and we search, and we try different solutions. Then we combine them together and generate an idea. So this is more like a tree-based structure. So they develop this tree of thought structure to allow the large language model to solve the problem. Yeah. And to build this tree of thoughts reasoning structure for the large language model, we need to, I mean, the authors answer four questions. So the first one is how to decompose the intermediate process into the thought steps. And the second one is how to generate potential thoughts from each state. Yeah. And the third one is like how to heuristically evaluate states because we need to pick the good one, then they move forward. Yeah. And the last one is what search algorithm to use. Yeah. So by answering these four questions, the authors developed the structure. I mean, develop the tree of thoughts structure. And yeah, and based on the results of this paper, they show okay, this method or this structure can I mean have had a better performance in solving this math problem, this reasoning problems. Yeah. So for the first one, for the first question, how to decompose the intermediate process. So again, so it's like depends on different questions. Yeah, different questions. So in this paper, they have three questions to want to solve. One is the game 24. The second one is creative writing, and the last one is the 5 by 5 crosswords. And for each, I mean for different for each of these, actually the thought decomposition I mean, it's different. For example, for the first one, the source is the three intermediate equations, like the intermediate steps to calculate. Then the creative writing is a short writing plan. Yeah. And the crosswords is the different words to fill in full clues. Yeah. Words to fill in full clues. So again, it's based on the different like a different question. They have different thought decomposition method. Yeah. But the second one, so based on the once we decompose the input into different like steps, then we need to, I mean, the second one is like we need to generate the thought or we need to generate the steps to solve the question. Yeah. And for this structure, for the tree of thought structure, they introduce two steps. Yeah, they introduce two steps. One is the sample and one is the propose. Yeah, so these two. So for the sample, actually, the sample is more like a chain of source prompt. It's independent. So it's IID source from a chain of source prompt. And this thought generator can be used to the creativity writing. Yeah, can be applied to the creativity writing. So I mean the sample means like it's only a sample and it's independent. So each generated source is independent. Yeah, it's independent. So it means we randomly generate different ideas and and each idea is the solve. And the second one, the propose, actually is more like this, like for the game of 24 or crosswords. So this one, I mean, as mentioned here, so this works better when the thought space is more constrained. Yeah, so this one is more like, okay, so it's like based on your previous generated source, then we generate the next source. It's more like a sequential process. Yeah. But here we use these two methods to generate the source. Yeah, generate source. And the third part, so once we generate the source, because this is like a tree-based structure, so we need to pick I mean, for each layer, yeah, we need to pick, okay, we select which node to move forward, to go deeper, right? So how do we select this? We need to evaluate. Yeah. So here, this is the third component of this method. We need to evaluate the state. Yeah, we need to evaluate the state. So again, for this method, I mean, this paper, they propose two ways to evaluate the state. One is the value. Yeah, one is the value. So it means, okay, once we generate a thought, then we evaluate. It's more like a loss function. So we evaluate, okay, if this generated thought can help us achieve the goal. Yeah, and give this sort as as a score, as a score. For example, when we solve the game 24, and if it generates a equation, and we notice, okay, it cannot solve the, cannot achieve 24, then the score is zero. But if it has the potential, for example, like a 4, 6, 1, right, then it has a very high chance to get the 24. Then we give it as a high score. Okay, then we use this to evaluate. And the other type is the vote. The vote is more like in this paper, they use this allows for the creative writing because we don't have a correct answer for the writing because it's a creative. So here we cannot generate a score, so we don't have the ground truth. So they use vote. So the vote is like we ask maybe the domain experts, or we do some like a statistical correlation to see, okay, if the generated one, if people prefer this one or not. Yeah. So it's more like a majority vote. Yeah. We don't have the correct answer, but we ask different people's opinion or different experts' opinion, and then we give this a score. And we use these two methods to evaluate the state quality. The salt quality. Yeah. The quality of each salt. Yeah. And the last component for the tree of thoughts is the search algorithm. So as I mentioned, we need to search and we need to reach the final solution. And if you see this tree, this tree-based structure, definitely the search algorithm in this paper, they introduce two. One is the breadth first search and one is the depth first search. I think so these two are the very, I would say, famous algorithm for the breadth first search. So for each layer, if you remember, tree has different layers. For each layer, so maybe we generate like a maybe 10 and we search the best five. Then for each, for all these five, then we we go to the next step. But for the depth first search, so for each layer we pick the best one and we go to the next one. Yeah, and then we go to the next layer and we again for the next layer we select the best one and we go deeper. But once we see, okay, if we along this path we cannot find the best answer, then we back to the previous level and we keep doing this. Yeah, keep doing this. So for by using these four components, we generate this tree of thought structure. Yeah, generate tree of thought structure. So the authors want to evaluate the proposed method, and they applied the tree of thoughts to three so three games. The one is the game of 24, and the second one is creative writing, and the third one is the crosswords. And they say if okay, this tree of thought structure can allow the large language model to solve these three questions. These three questions. Yeah. And this slide shows the performance of the tree of thoughts large language model in the game of 24 cases. Case. So here you can see, okay, so they use the breadth first search as the search method, and for each layer they generate different like source, and they pick the best one, and they pick the best one, they move forward, and they also generate several, and again they pick the best one. And here, if you can see, okay, so they generate they generate like for each step they evaluate if you see this red one, the 9 plus 4 plus 9 equals to 13. Then once we generate this, okay, the remaining four numbers are 10, 13, 13, and it's impossible to generate to 24. Okay, then the score is zero. Okay, but if we use the 10 minus 4 equals to 4 equals to 6, and then we have like then we have uh the we have three numbers is like 6, 9, 13. So these three numbers has the potential to generate a 24. Okay, then this has a higher score. Then we select this and we move forward. Then they move to the next step. So we using this tree-based method. We keep searching and we keep evaluate. Evaluation evaluating and we find a better one, and we move to the next step. Right? And this slide shows the statistics of I mean, I mean, shows the performance of the tree of thoughts structure in the game 24. And here you can see compared to the chain of thoughts. So the successful rate and the success rate of solving the question jump from the 9 to 74. Yeah. If, for example, if we use the breadth first search, and for each layer we only generate one, still the tree of thoughts can have like a 45% accuracy, but the chain of thoughts can only have a 9% accuracy. Yeah. If the breadth first search, the breadth equals to 5 means each layer will generate 5 different uh, potential solutions, then the accuracy jump to 74. It has a huge jump. Yeah. So again, using the other two images also show, okay, the tree of thoughts has a better, well, I mean, better performance, actually much better performance. Yeah. And this slide shows the tree of performance of the tree of thoughts in the creative writing. Yeah. So again, using this one, they use the breadth first search as the search algorithm. Yeah, but the depth of this has only, I mean, the depth is like I mean, kind of like shallow compared to the game 24. So here they only have like two layers. The first one, they generate a plan. So if you see, based on the inputs, it generates like a yeah, the 5 plans, and each plan they generate like the plan for the large language model to generate this creative writing. Yeah, and they vote. They vote different plan, and they select the best plan. And based on this best plan, okay, they generate the creative writing, the passage. Yeah, and again they vote the passage and they select the best one. Yeah. So again, they're using this to generate the final answer. Okay. And they compare, I mean, they ask the experts, yeah, to compare the performance. Again, yeah. So here, you can see from the figure B. So they ask the experts' opinion and they generate like this human coherency comparison. So people, I mean, based on this, they have like they test 100 examples, and for these 100 examples, people think the creative writing generated by COT better than TOT has counts for 21. Its equal counts for 38, but they prefer TOT, and they think TOT is better than COT actually counts for 41. Yeah, and again they use the ChatGPT-4 coherence scores. The TOT also shows better performance compared to the an input output prompting or COT prompting. So all these two figures shows the TOT has a better performance in this like creativity writing cases. And I mean, this slide shows the performance of the tree of thoughts model in this crosswords method. And for this one, they use the depth first search as the search engine. And for each layer, okay, they select the best one and they move. I mean, they move to the next. Yeah, they move to the next. And once they move to the next, they will assume, okay, this number already occupied the grid, and they use for example, the answer from the previous two to do the evaluation to see, okay, if the generated words is possible or impossible. If it's impossible, then we move back. So if you notice, there is a backtrack. They move to the previous layer and they generate another word, and they keep doing this until they fill out the crossword and they fill out all the numbers. Okay. Yeah. And again, compared to the input output and the chain of thoughts, the tree of thoughts has a obviously much better performance if you see the success rates of the words. So the tree of thoughts can generate 60 words, okay, but the other two can only generate on average, but other two can only generate like 14 or 15 words compared to the TOT. Yeah. So all this method or all these results shows the tree of thoughts has a better performance in solving the complex or reasoning or long-term not long term, but it's more like reasoning questions. Yeah, reasoning questions. Yeah. So based on the results, we can reach to the conclusion. So the TOT framework, the tree of thoughts framework improves the problem-solving capability of the large language model. Yeah. By enabling the systematical exploration of the reasoning paths and and the self-evaluation of choices and the strategic backtracking, which enhance the performance in tasks requiring the complex reasoning, like the Game 24, creative writing, and the mini crosswords. Yeah, mini crosswords. And also, compared to the chain of thoughts, the tree of thoughts actually extend beyond the structure. Yeah, by incorporating the search algorithm and the heuristics for evaluation. Actually, they expand the the chain of thoughts to a tree. Or in other words, we can say the chain of thoughts is a very special case of tree of thoughts. Yeah, of tree of thoughts. And this allows the adaptation to diverse tasks. So later we can use this tree of thoughts to solve more complex problems. Yeah. And the question based on the like the this paper, we can I mean we can also have some questions. So um, the first one, I mean, once I review this, one question I'm thinking is, okay, the tree of thoughts definitely for these reasoning questions is better, right? It's better because it has a more, I would say, complex reasoning process. We keep searching and we keep like evaluating the I mean the generated thoughts. But if we compare the computational efficiency or the core or the cost compared to the like the chain, I mean the chain of thought or the input output, then it's hard to, I mean it's hard to see the tree of thoughts is the better method because I also try to use this, and if we use ChatGPT using the tree of thoughts, it's very expensive. It's very expensive. So I saw like a 10 game of 24 questions using the tree of thoughts. It may cost me $5. Yeah, for the I mean for the like then to pay to the open AI. Yeah, so it's expensive. It's very expensive. So if we consider this, if it's better or or not, and if let's say it's expensive, then in the future, how can we improve this? Yeah, how can we improve this? And the second question I have is, so this paper actually, yeah, so this is the first paper introducing this. So I'm thinking, so this paper they just use to some games like Game 24 or this like crosswords. Yeah. So, but this method actually is promising because it can solve the reasoning process. So can we use this to more realistic applications like the robotics, right? So if the robots can have this reasoning process, then the robots can understand the surrounding environments, can maybe complete the assigned tasks without maybe human assistance, right? Maybe can self like explore the world. Yeah. So this is one. And the second one is like if we can use this to, I mean, if we can apply this method to the real mass problems, yeah, like the self improving, yeah. So can we apply this to those scenarios? So if we use this method to these scenarios, do we have any like challenges? Yeah, do we have any challenges? And how we can improve the efficiency of this complex searching method? Yeah. Okay. So this is the question I have. Yeah. Yeah, that's all. Thank you. Thank you for reviewing this this presentation. Yeah.